Lesson 3 notes, acceleration. So we looked at acceleration in Lesson 2 notes. We have this definition already in our Lesson 2 notes, and we're going to go more in depth this time. We're going to be doing some calculations. But let's review. So acceleration is the rate at which velocity is changing. So measuring how someone's velocity or speed, or an object's velocity of speed, is changing. Now, remember that velocity is a measure that has both direction and magnitude, right? Velocity, you state how fast something's going and then what direction it's going in. So if either the speed is changing or the direction is changing, those are both acceleration. Now we all experience acceleration in our bodies when velocity changes. So let's say you're driving in a car, right? And you're at a stoplight, or maybe you're just getting onto the freeway and you're really speeding up, right? And you can feel it in your body. Your body's pressed back against the seat, right? Or if you stop suddenly, your body will, you're having negative acceleration, slowing down suddenly, and your body will pitch forward, and hopefully you're wearing your seatbelt and that catches you, right? Or you might experience it on a roller coaster. Now we also experience it if we're in a car and we're turning a corner, right? Our body will resist the movement and it will kind of lean against the opposite direction as you're turning. So anytime our bodies really experience acceleration. And so we can measure it mathematically with this formula. And we looked at this formula before. This delta means change. So acceleration is calculated by figuring out the change in velocity from the start of the time you're measuring to the end, divided by the change in how much time has passed from when you started to finished measuring. So this is the final velocity minus the starting or initial velocity divided by how much time has gone past. Here's another way of writing that same equation, where we write v of f, right, is final velocity, and v of I is initial velocity. So it's the same thing as this, divided by the amount of time that's passed. So we're going to do some math with that. Okay. Oh, and remember that when something is going the same velocity, there's no acceleration. And so we feel that in our bodies, right? If we're taking, we got on this freeway, got on the on-ramp. Once we're going the constant velocity, same speed on the freeway, our bodies are no longer pressed against the back of the seat, right? It feels within our bodies kind of like we're not moving. We notice that a lot in an airplane, right? We really feel the acceleration as we're taking off, but once we reach our cruising speed, we are no longer pushed against the seat. Speeding up is positive acceleration and slowing down is negative acceleration. So let's do a little math with this. So what you have here is a distance versus time graph. So let's look at what's happening. 2 seconds have gone by and the object we're measuring has gone 10 meters. Another 2 seconds goes by and the object went another 10 meters. So that's the next data point here. Another 2 seconds goes by, and the object has now gone another 10 meters, right? 2 seconds, 10 meters, so very consistent speed. Every 2 seconds that goes by, object has gone another 10 meters. So let's fill in this chart. Now we're going to use our distance equals rate times time formula that we used in the last notes. We're using the term velocity this time, so let's write our formula as distance equals velocity times time, because velocity and rate refer to the same thing. So now we're calculating velocity. So let's solve for v. So we're going to get v by itself. So we're going to divide both sides by t, and what we get then is velocity. That cancels. Velocity equals distance divided by time. So that's what we're going to use to calculate the velocity for each of these time intervals. Okay, so for the first time interval, 0 to 2 seconds, so we're going to do d divided by t. What is the distance that they went in that? So here's the time interval, right, 0 to 2 seconds. So we can put the time that's changed is 2 seconds here. And the distance traveled would be 10 meters, right? Object traveled 10 meters in 2 seconds. Then we can do a little math. 10 divided by 2, we get 5. And then our units are meters per second. We've seen that before for a unit. Meters per second is a common measure of speed or velocity. Okay, now let's do the next time interval from 2 to 4 seconds. Right here. Still 2 seconds have gone by. It's a change of 2 seconds. And now another 10 meters, gone from 10 meters to 20 meters. So a total distance of 10 meters has been traveled. Again, speed is 5 meters per second, or velocity. Same thing for the next time interval, right? 2 seconds have gone by, another 10 meters have been traveled. And what we can see for this particular object that we've graphed, the speed is not changing. It's 5 meters per second for every time interval. So now what we're going to do, and this is new, we're going to do a velocity versus time graph. So now time is still on the x-axis, but on the y-axis, instead of distance, we're going to graph the actual velocity. So we're going to take these numbers here, and we're going to graph them. And it's the units for the y-axis are meters per second. The units for the x-axis are seconds. So let's graph each of these points. So we've made an xy table, right? So for the 0 to 2 interval, the velocity is 5 meters per second. So that would be right here, right? 5 meters per second. So that's we're going to place a dot there. For the interval from 2 to 4 seconds, this interval right here, the velocity was also 5 meters per second. For 4 to 6 seconds, velocity 5 meters per second. Right? So for all of our time intervals, the velocity was 5 meters per second, and we can connect these. And what we see is a graph, a velocity versus time graph that has 0 slope. Okay, we'll talk about that in a second. Now let's calculate what the average, what the acceleration was. So we're going to use our acceleration formula from up here. So our acceleration is, right, acceleration equals the final velocity minus the initial or starting velocity over the amount of time that's elapsed. So for this whole time from 0 to 10 seconds, the final velocity at the end at 10 seconds was 5 meters per second. The initial velocity was also 5 meters per second. The total amount of time that passed was 10 seconds. And so we get 0 meters per second divided by 10 seconds. 0 divided by 10 is 0. And let's look at what our units are. We have meters per second per second. So this second is on the bottom of that fraction up there. So we're actually going to move it down here. So we're going to say 0 meters. And then we're going to have seconds times seconds here. And how we're going to write that is 0 meters per s times s, or seconds times seconds, would be seconds squared. That's an important thing. Meters per second squared, that is the units we use to measure acceleration. Okay, so the units are meters per second squared. That's how the units for acceleration. And you're going to answer a question about that there in your video. Okay, coming back, let's do another example. Okay, so now we have a different distance versus time graph. Here we had very consistent speed, right? When we see a straight line, that means for distance versus time, that means a consistent, non-changing velocity. Here we see we have a curve. So let's see what's going on there. So for the first interval between 0 and 2 seconds, we have the time elapsed is 2 seconds, right? So we're still using velocity equals distance divided by time, right? Now, the distance that has been traveled here is only 5 meters, right, for that first data point. So it's going to be 5 meters. So if we divide that, we get a decimal. We get 2.5 meters per second. Okay. What about the next time interval? So now again, 2 more seconds have passed. So we're looking at these 2 seconds from 2 to 4 seconds, right? And the total amount of speed of time, not time, sorry, the distance that's been traveled in that time is, so each one of these squares represents 5 meters, right? So 5, 10, so 10 meters has been traveled in that time interval. So that now we're speeding up a little, 5 meters per second, okay? Let's do one more, and then you're going to do a couple in your notes here. So the next one, we have another 2 seconds have gone by, right? But now the distance that's been traveled is 5, 10, 15 meters, right? So we get 7.5 meters per second. Okay, now you're going to do, oh, I guess we don't have this one here. I'll cross that out, so it's just 8 seconds. So now we're going to have, you do this one, and then you're going to come over here and we're going to graph it, right? Okay, so now we're graphing velocity for each time interval. So at 2 seconds, the velocity was 2.5 meters per second. So that would be right about here. Right? At 4 seconds, the velocity was 5 meters per second, right? So we're graphing these points, right? There's that point. At 6 seconds, we have 7.5, right? And then you're going to graph yours that you figured out for 8 seconds. Now, we can go back down. Let's see, what about 1 second? Well, we didn't calculate that, but we can see on the graph, here is 1 second. It looks like 1 second was going to be somewhere around there, somewhere around 1 meter per second, right? So notice here, we were to connect these dots, now we get a line that has a positive slope. Positive slope. So what does that mean? Here we had a 0 slope and our acceleration was 0. No 0 slope. Now we have a positive slope. Let's see if our acceleration is positive. So we're going to use our formula. Acceleration equals v final minus v initial over time. So we'll do this one together. The final velocity, I guess we didn't do this one, and if you did this correctly, you would have got 10 meters per second. So it would be 10 meters per second minus 2.5 meters per second divided by 8 seconds. So we get 7.5 meters per second divided by 8 seconds, and that's going to be, I don't have my calculator out. You guys will work that out. It's a little less than 1 meter per second squared. So it's a positive value. And we saw that this person, so you're going to answer in your notes, was this object speeding up or slowing down? So did it have positive acceleration or negative acceleration or no acceleration? So you'll answer that in your notes. Okay. Next video, we'll do page 2.